I'm going to talk today about the power of networks and the challenge of mapping an increasingly complex world. And I'm actually going to start with this talk with trees. Trees have actually been, really important religious symbols over the ages. We can see trees all the way back from ancient Babylon to Judaism to, of course, Christianity. But even more than religious symbols, trees have really been important knowledge classification systems throughout the ages as well, mapping a variety of aspects, mapping the blood ties between people, of course, mapping the main characters and stories told in the Bible, mapping also the main areas of science, and even mapping, of course, the species, the various species in the planet, and again, using the tree metaphor on and on and on. This widespread metaphor, it's so popular because it really expresses human desire for order, for symmetry, for hierarchy, for simplicity, for balance and unity. Trees are really an embodiment of the simple way we like to look at the world. And one of the oldest trees of knowledge known to man, this was actually devised by Aristotle himself, this beautiful tree of knowledge that tries to come up with a universal structure for everything that we know across the world, from living bodies, animals to humans. And this was considered to be the first tree of knowledge, but then of course we have grown a lot more knowledge since then. In my view, we are really in this turning point from trees to networks. We are really facing a paradigm shift in the sense that trees are now no longer able to really accommodate the inherent complexities of the modern world. And this happens, of course, for a series of reasons. One of the best articles I've read on this topic was written by Warren Weaver, American scientist Warren Weaver. And in 1948, he wrote an article on the topic of organized complexity. And Weaver basically divided modern science into three different stages. The first one covering the 17th, 18th, and 19th century to what Weaver considered to be problems of simplicity. During this period, scientists were primarily concerned how one element influences the other. Moving to the second stage of modern science, scientists really became aware that it's not just one or two elements going on. There's a lot more elements in our planet. But to some extent, the way that they were sort of connected was fairly chaotic, very random. At least it was thought during that time, discovering at least the first half of the 20th century to what Weaver considered to be problems of disorganized complexity. Moving, of course, to the end of the 20th century and the current century where we're now, scientists, of course, became much more aware. It's not just a huge variables going on. There's not just a huge number of elements in our planet, but they are also highly interconnected and highly interdependent to what Weaver considers to be problems of organized complexity. And you can really see these problems of organized complexity in a way that trees are unable to sort of suffice in many different areas. We can see those problems of organized complexity in the way we try to unravel our ecosystems. So no more we have this, extremely simplified predator versus prey diagrams, right? We are understanding our ecosystems in a much more complex way. This is a diagram of all the species that interact with cod, actually close to 100 species interacting with cod off the coast of northeastern Canada. And you can really see, actually, cod is right in the middle. You can actually hardly see because of the massive lines, but it's kind of incredible, the amount of interactions that exist within those species. Again, this complexity of ecosystems that we have around us. We also see these problems of organized complexity in the way we try to decode our own brain. So, before we used to think about the brain as this modular, centralized organ where different area was responsible for a given set of actions or behaviors. It's kind of appealing to think about the brain as a central element responsible for a variety of actions. But of course, it's not central at all. The more we realize that, our brain is really almost like a music symphony played by hundreds and thousands of instruments. This is one of the most complex maps of the brain. It was created by the Blue Brain Project, which is very much related to the Human Genome Project. It's at least the same kind of scale. And it's mapping 10,000 neurons. It's mapping 30 million connections between those neurons. And it's just 10% of the human neocortex. That's it, 10%. It's really remarkable to really have the first sort of map of the inherent complexities of the brain. We also see these problems of organized complexity in the way we categorize knowledge. This is one of the most beautiful trees representations. This was created for the French encyclopedia the biggest encyclopedia at the time, created by Diderot and d'Alembert, the big sort of encyclopedia of enlightenment. This really represents that enlightenment in many ways. But even though it was brilliant at the time, 1751, it really represents knowledge as a tree where branches don't really touch each other, right? I mean, they touch in the diagram, but they don't. They have no connections. They have no ties between them. It's individual branches that branch off, and there's no connection whatsoever. In comparison, you can actually see here, these are two maps of Wikipedia. And Wikipedia, of course, all of you know, it's really one of the largest rhizomatic structures ever created by man. You can really understand that, by looking at these maps, and of course using Wikipedia, as we have done probably several times already, that knowledge is really highly interconnected, is, just like a network, really. I mean, you can actually see here some topics like mathematics and others, and they have immense connections with other disparate areas of knowledge, apparently disparate, but sharing a lot of ties. We also see these problems of organized complexity in the way we try to organize ourselves. And this has been, again, with us, throughout time, especially after the Industrial Revolution, where this notion of top-down hierarchies became so prevalent in, institutions, society, companies, governments, etc. But this is, the typical organization chart, where, again, the top-down all the way from the president to the individual workman down below. But of course, we are much more idiosyncratic beings, as we all know. And the internet is really drastically changing this paradigm of looking at social structures from a hierarchical point of view, a tree structure. This is a map of online social collaboration between Perl developers. And Perl is a very famous programming language. And here you can actually see thousands of people collaborating in a variety of projects and, sharing this very network structure, which is the opposite of again, any sort of hierarchy. There's no leader per se. They just freely collaborate online to achieve a given project. We also see this kind of paradigm shift in the way we look at nature, right? In the way we order nature itself. So the image that you have on the left side, as a big fan of Darwin myself, this is actually the only illustration that Darwin had in The Origin of Species, what he denominated to be the tree of life. And of course, since then, over the past 150 years, many scientists have evolved this tree of life. And of course, on the right is the typical top-down hierarchical structure that we have to categorize every single species on Earth that we know. Again, all the way from domain to the individual species, Homo sapiens, that you see for the human. But this has actually been changing drastically. Very recently, scientists really discovered that overlaying this tree of life, the original tree of life by Darwin, there is a dense network of bacteria. And this bacteria is actually tying very disparate species and making them really close together. And if you consider that roughly 90% of the human body is made of bacteria in our cells, you can really understand the significance of this discovery. And a lot of scientists are really calling this the web of life. It's not the tree of life anymore. It's the web of life. It's the network of life. Networks are truly everywhere. It is this omnipresent structure. The brain is a network of nerve cells connected by axons. Cells themselves are, of course, networks of molecules. Societies, as we all know, are networks of people linked by different types of ties. Of course, on a larger scale, you can think about food webs and ecosystems, as we saw before, as networks of species. And of course, networks pervade human technology, from the internet, power grids, and transportation systems. And then finally, I would just like to end with a little bit of a teaser. Is there such a thing as a universal structure? I love this comparison. So what you have on the left side is the neural network of a mouse from 2006, which at this scale is pretty much similar to our own. And then on the right side is the Millennium simulation. It was the largest and most realistic simulation of the growth of cosmic structure and the formation of galaxies. It was able to recreate the evolutionary history of approximately 20 million galaxies in approximately 25 terabytes of output. And here again, you have the same comparison, just at a different scale. Again, a neural network of a mouse, again, very similar to our own. And again, the Millennium simulation at a different scale. And for me, coincidentally or not, I just find this comparison striking in so many different levels between the smallest scale of knowledge, of human knowledge, and the largest scale of knowledge, the universe itself. And how everything is really, really so similar. Are we in the presence of this universal structure, being the network? even more than the idea of representing these complex systems is the need for a new way of thinking. And this new way of thinking is about this pluralistic way of thinking, that everything is interconnected, everything is interdependent. We're almost going back to the polymath, the Renaissance man mentality, that it's not just about being a specialist in one area. You need to know a little bit of everything, or at least create outbound ties that you are able to learn from other disparate areas. And I think this is the most beautiful aspect of knowledge that we can take into consideration by looking at this network thinking. It's more important even that we actually make that mental shift, because I think there's immense benefits that can come from that, this network outlook of the world itself.